Okay, good morning or good afternoon. This is the TJ Distance Learning walkthrough for Math 8, assignment for May 26 through 29, 2020, pages 369 to 370, the inquiry lamb of parallel lines. And in this week, we will be actually working in the very beginning of volume 2. So as you open up your book, a few pages past the beginning, table of contents, page 367, page 369 is at the very, very beginning. So you can see right after this is the first lesson in geometry, which is chapter 5. So this is the very start of chapter 5, an inquiry lab of parallel lines. And it reads, what are the angle relationships formed when a third line interacts with two parallel lines? So we're talking about something that we have talked about before. Angle relationships, we did this in Unit 1, formed when there's a third line that goes through two parallel lines. A lot to unpack there. We have a picture of here of a newspaper route, two parallel streets, Main Street and Columbus Way, and then we have a line intersecting them. And we had a lot of vocabulary early on. We called those transversals. So essentially what we had in Unit 1, we had parallel lines, which we usually called line 1 and line 2. Line 1 we would call L1, and line 2 we'd call L2. Then all of a sudden another line comes through at some angle. You can imagine this is a train tracks, and a line in old towns, and some of the towns would have a transversal line. We'd call this a transversal. And we call it line T. It stands for transversal. And these would be line 1 and line 2. And it creates some really, really nifty angle relationships. Let me grab a red pen here real quick. There it is. We would always mark the parallel lines with a red marker or a red pen. With generally, I would put 2 for parallel lines here, showing that line 1, L1 is parallel to line 2. And then we have our transversal line, and it creates a unique angle here. So we'd have an angle here, and then we'd have a different obtuse angle created here, and we'd use 2 markings for that. And then this other angle here, if we look at it, this forms a semicircle. And I'm not going to go into in-depth of proving that this angle is congruent to that one, but we call those vertical angles. So this would only have a single mark, and then this one would have the double mark. So everything with a single mark would be congruent. And we usually name these in order: angle 1, 2, 3, and 4. We have corresponding angle on the other parallel line. See, this line is going straight, creates an angle that's congruent to that one. The vertical angle is congruent, so we have 5, 6, 7, and angle 8. And then we have lots of ways we can name vertical angles are congruent. That's angle 1 is congruent to angle 3, and also 5 and 7. Those are vertical angles. And then we have corresponding angles, 1 and 5. There's a lot of them. So let's name a corresponding angle. Would be angle 1 is congruent to angle 5. You could find other ones. 2 goes with 6 because it's in the upper left. Corresponding on this transversal is creating congruent angles. corresponding angles. We have also inside, remember we talked about the interior here versus the exterior, the interior between the parallel lines. If they're on alternate sides of the transversal line, these are on alternate, we say alternate interior angles are congruent, like 3 and 5. Angle 3 is congruent to angle 5. So we have the congruent angles. And then we have another situation where we have supplementary angles. They sum to 180 degrees. So what does that mean? It means that anytime you put your, if I put my straight edge down, look at that. What is this creating from here to here? From here to here is a semicircle, which is 180 degrees. Well, if I did it here, I'd have the same thing. Look. Look at this. Now I have from here to here would be another semicircle, right? Well, we apply that and we could say, well, that's why this angle plus this angle has to add up, you know, to 180. So angles that are right next to each other, angle 1 plus, or I should say the measure of angle 1, measure of angle 2, add up to 180. They are supplementary. That red pen's not working great. But what else is supplementary? Well, alternate exterior angles we're going to look at. But this is an exterior. Those are congruent. But let's say if you're on the same side. So if I'm on the same side right here of 3 and 6, see how that is right here, the single mark, double mark added up to 180. Well, this is the same single mark and double mark. So that way we know the measure of angle 3 plus the measure of angle 6 equals 180 degrees. And we call that same side interior angles are supplementary. You can name other ones besides that, but let's stick with these key 5 here. Okay. And now we can look at it. Parallel lines have special angle relationships. You will examine those relationships in this activity. We have 1, 2. So now I don't like how they did this because I like to start like a 1, 2, 3, 4. So I keep it the same as the quadrants, but they've changed the number system. So you can use a protractor and angle relationships. You have previously learned to find the measures of each numbered angle and record in the table. Now I'm going to go back to this big one because I'm going to show you how to use your protractor. If I put my protractor, I'm going to put the target right where an angle is formed. That's the circle target area. And then one line has to be on 0. Your 0 can start on this side or on that side. So if I go here, I'm measuring this angle, I'm going to go 0 and up to 122. But I'm going to measure this angle 5 here. So I'm going to start at 0, 0. Now I'm going to be counting on the reds, 10, 20, 30, 40, 50, just short of 60 by 2 degrees, so it's 58 degrees. Once you have one angle and you're dealing with parallel lines, you can find all the other angles. So 180 minus 58, I'm going to borrow here, 7, 10, 2, 122 degrees. And now I'm rolling 58, 122. This is 122, 58, 122, 58. So that's, once you have the pattern, then you're pretty good to go. I just need to find one angle. So let's go and find angle 2 here. Again, I'm going to find angle 2, I'm going to be working on the inside here because I'm starting this ray at 0 going this way. I could start over here. I'd be on the blue on the outside, and I'm going to have an obtuse angle. This I'm going to need to draw out further because I cannot read it. So I'm going to extend this line as far as I need. I'll extend this line as far as I need. Just using it as a straight edge right now.
Are you online?
Yeah, I'm recording. And here I have 0, 10, 20, 30, 40, 50, 65 degrees. And now you should be able to find, once I have 65 degrees for angle 2, you should be able to find all the other angles. Now, what do I know about from here to here? So this angle plus this angle. I know that 65 degrees plus the missing measure of angle 1 has to add up to 180. So you take your 180 minus 65, borrow here, and then go ahead and finish your subtraction, and you have this angle. Once you have this angle, you have that angle. These are vertical, so they're congruent. You should be able to fill out this chart. Colors the angles that have the same measure. So you'd pick a color. For example, if you picked red here, you could color it red. You'd color that one red. Again, alternate interior. And you can tell because they are, these are also acute. So that's another giveaway. Describe the position of the angles with the same measure. So you have your vocabulary from previously. They're asking with the same measure. So they're asking about congruent angles. Name the vertical angles, name the corresponding angles, alternate interior angles. Turn the page. You can always pause this video if you need to. Work with a partner if the measures of angle 1 in the figure at the right is 40 degrees. Okay, so we got 40 degrees here. They want you to first determine the measure without using a protractor. Okay, well, if this is 40, this angle, and then this angle, sorry, not drawing the greatest. 1 and 2 have to make a semicircle, which is 180 degrees. So 40 degrees plus what adds up to 180, and then you can find that, and that answer of question mark is going to be your angle measure there. Then you're going to grab your protractor, extend out your lines, set your 0 here, and then test your theory by measuring each angle. Okay? If you don't have a protractor, you can make one. You can use a clear plastic or something, and you can make a semicircle and 0, break it up as 90, and then 1, 2, 3, 4, 5, 6, 7, 8 marks between 0 and 90. So you make a semicircle, you can lay it on top. Name these angles, and then we get to 8. What is the relationship between the two horizontal lines? Refer to the figure at above. What relationship do these what do they mean by horizontal? Those are lines that go left to right. So we go up here and we look at line 1 and line 2. What do we know about two lines that are never crossing? And I'm kind of giving it away with the symbol we use. What is true about the measures of angles that are side by side? Okay, I think they're talking about angles that are side by side, as we are talking about angle 1 and 2 here. What do we know about 1 and 2? Again, you want to use the language. You want to use the language here that is building your vocabulary. If two angles add up to 180, you want to call them supplementary. Okay, 10. Congruent angles are angles that have the same measures. Describe the positions of the congruent angles. Again, you have congruent angles come up in 3 positions. Vertical angles, but you want to name them from this figure up here. vertical angles, you're going to use corresponding angles, and alternate interior. You can describe them in words, where they're located. This is a lot of big words in it. Interior, what does that mean? Alternate of what? The transversal. Okay. 10. Describe the position of these, all those, there's 3 of them. So name all 3 of them. And finally, create. Make a conjecture. Oops, I hit something here. Okay, sorry about that. I don't know why it's doing that. Make a conjecture. Draw a set of parallel lines cut by another line. Draw a set of parallel lines cut by another line. Estimate the measures of the 8 angles formed and check your estimates by measuring each angle. All they want you to do, and you could do this on a separate piece of paper, is you can take your lines, or you can do it on this paper if you have room. Take your 2 lines that are parallel and then cut it with a transversal. And unless you do it by 90 degrees, if this transversal line, is anything other than 90 degrees, you're going to get 2 sets of different angles, and you want to measure those, okay? Remember, you're drawing these 2 lines parallel. Now, you don't have to draw them horizontal. You can draw the 2 lines vertical and then a transversal going diagonally across. And finally, answer 12. What are the angle relationships formed when the third line intersects with 2 parallel lines? Okay, so that's what we've discussed this whole time. The angle relationship formed when the third line interacts with 2 parallel lines. There's only 2 angle relationships, right? There is these type and these type. Okay, well, good luck. This, again, is due Friday in Google Classroom on May 29th.